All right. So we are talking about the joins here. As I said, like joins are basically helps you to combine more than two or simply multiple tables. And when you want to the result set to be one. Okay. So A table, B table, C table, D table is combined together in order to come with a result called one table. That's a final table which you are going to use for your reporting or analysis, because you're combining sales table, you're combining finance table, you're combining HR table also finally to see a final view. Okay. So the question which arises here, why can't we use the operators, right? So in case of a union, we know what exactly the consequences. We know when you're using union all what happens, when you use except what happens, when you use intersect what happens. They have their own blindfolded rules there which we need to follow. Even if you break one rule, it is not going to give the right result for your application. So basically joins helps you to whatever the challenges you are facing with the operators, we can simply manage with the help of a joins here. All right. So as I said, the joins are two types here. Okay. One is ANSI format. One is non-ANSI format. So ANSI format is nothing but the new style of format, and this one old style of format. Now, okay. So in this scenario, when you're trying to use ANSI, how we are going to recognize, basically I'm using ANSI format, new style format, how we are going to result. The keyword which is used is on keyword. Okay. Whenever you find any joins with a keyword called on, then it is going to be a new style. And whenever you see with a where condition, then it is going to be a non-ANSI or old style format. All right. So in this scenario, in the a new style format, what are the different type of joins we have and how we are going to use that based on your requirement. The very first one comes here is inner join, which is also called as, if you find somewhere like simple join, which means same. All right. Inner join or simple join, both are same. Now the next one is full join. Let me put everything here so that we will discuss one by one. Full outer join, both are same. Full join or full outer join means same. Next we have something called right join, and next we have something called left join. All right. So these are the other names which we frequently find in the relational database management. So these are the most common four types of join: inner join, full join, right join, left join. The words are really indicating you what it can do for you, but let's see in the action what this can do. And the next one, we have something called cross join, which is not that popular. Okay. Whenever there's an interview question or wherever you read, you'll always find four types: inner, full, right, left. But let's try to discuss about the cross join also. And the next one, natural join. Okay, so let's assume now for the ANSI format, new style format, we have a 6 types of joins. In case of a non-ANSI, we have something called equi-join, non-equi-join, and we have something called self-join. Okay, it's more of English words. You can see inner join, full join, right join, left join, cross join, and we have a natural join as a part of a new style. And the old style formats, we have equi-join and non-equi join and self join. Let's try to do each and every join practically, see what kind of results we are going to find. Okay, so for that we need to have two tables. So I'm not in the interest of time, I'm not creating, because we already have two tables which we created last week. Let me explain you how the tables looks like. It's a very simple tables which I've taken. Okay, very simple tables I've taken. If I take millions rows, it's really impossible for us to understand how the tables are joined together and what kind of results you are getting. So let us not spend time on understanding how the data is combined millions of rows. But if you look at a small tables, you can easily understand how practically it's giving you a result by using these type of joins. So let's talk about the inner join here. Inner join basically returns all the rows. Let me write here. Inner join returns all rows from multiple tables instead of saying two tables, multiple tables, where the join equality that's it. What inner join is going to do is it return all the rows from multiple tables. Let me see tables here. Tables where the join will try to see the equality condition is met or not. So what does it mean exactly? Let's try to see in a pictorial uh, uh, in the form of picture. Okay, you might have already when we studied some 10th class or something, like we might have seen something in the mathematics. Okay, intersects, unions, set operators. So let's try to do some kind of a graph here which will understand how the inner query works. Let's assume this is a table A and this is your simply table B. Okay, now why we are trying to combine two tables or multiple tables? In simple, we want to get a result. This is your A table. Let me put as A, and this is your B table. All right, let me make bigger. This is A table, this is B table, and at the intersection between these two tables, what happens when I'm using inner? So every type of join will have a different results. It always depends upon your requirement, what join is best for me as per my report is concerned. So A, table B, whenever you find, let me hide this. Okay. The intersection happens here. The intersection basically happens at this section. That means it will try to return all those rows from two tables where the joining condition is matching. That is nothing but in the A table, there must be some set of rows, and in the B table, there are certain set of rows which are matching, exactly matching. Those are going to be retrieved as a set of your final table, that is the C table. All right. This is a simple graphic presentation to understand how exactly the inner join works. So let me put this into your Excel so that you can refer this. Okay. All right. So now let's try to see this information. We have a student table. We have a course table. There are two tables here primarily. Maybe you can take it as an employee table and here a department table, or else you can take it as a student. You can take it as a product table. Here the orders table. So the situation might be anything. Now the real purpose here, we want to join them together in order to get the results. So before getting into more, we need to understand what are the rules to be followed here, because without rules, we cannot do anything as such. Okay. So what are the rules to be followed here is the column names may be different. The number of columns are different, doesn't matter. The data type can be different, doesn't matter, because you can just compare with your set operators. There we have a rigid rules. Here it doesn't matter, because here if you look at very clearly, I have it 4 columns in the A table. In the B table, I have only 3 columns. That means there is no rule here. That means you can have a number of columns in the both the tables, doesn't matter. Second thing, here we have a student ID, which is a number format, nothing but integer. Course ID, which is a different altogether, but say integer data type, doesn't matter. Here we have a name character. Here we have a course name, which is a character. Here we have a location. The third column talks about integer. So the data types are not matching, still doesn't matter here. The columns may not be in order. Completely, I'm talking opposite to the set operators now. Columns may not be in order. Data types may not match. But what are the rules to be followed then in that case? Only one condition should meet. That is, in the both the tables, there should be one unique column which they can talk to each other. For instance, here we have something called student ID. The column name is student ID. Here the column name is CID. Here we have a S name, we have a C name, which are completely different, right? This is a student name. S name is nothing but student name. C name is nothing but course name. Okay. Here, this is something called fees actually. Okay. This is a table which is talking about what is the course ID and what is the course name. So whenever I want to refer Excel, I will be referring 10. Whenever I refer Tableau, I will be saying 60. Whenever I want to refer 10, that means Python, something like that. I've given some course ID. So this is my static table in my organization or my institution. Okay, where I also mentioned what is the fee about it. Okay, this is my student table. Whenever somebody is joining, I'll first try to take its ID. I'll register with some ID. I'll take his name. I'll also record from which location is joining this course and also what is the course is opting for, because I cannot mention directly your Excel. Rather, I want to create a separate table where I have the complete details about the course. So in this format, we have a student table. In this format, we have a course table. Here, I have employee table. Here, I have a DPT table. In this employee table, all the employee information. In the department table, I have the complete department related information. But how this both the table can marry each other, both tables can talk to each other, because if I look at my previous set operators, everything should be size, height, shape, everything should be same, data type should be same, order should be same, the number of columns should be same, very strict. But when I come to this joins, the rules are completely different. But only one condition we need to remember: whatever the column you have, the column values should be same. For example, here we have a CID, which stands for course ID. Here I have something called course ID. So intentionally I've taken the column names differ. That is also doesn't matter. The column name may not be same. Doesn't matter. If it is same, it's fine. If it is different, still fine. So what matters here is the course ID, what we have in the course table should have that numbers here. It's not mandatory. For example, I have only 4 students. Who is not every student is opting for all the courses, right? If I have 100 students, all the 100 students might be only opting for Excel and VBA, not SQL and Click and Tableau. So here I'm just recording all the student information. Here I have a static table which my institution is offering the courses, only these courses, and these are the only fees for that. That's it. This is a static table. It will never change. Maybe if I'm adding a new course, it will start with a new course ID. But again, the course ID will not be repeated. And whoever is opting for, let's say this is 70, this is Python, and course is 500. That means if somebody is looking for Python course, then instantly, for example, Neelima from Mumbai wants to join for a Python. So the course ID will be 70. The same lady again wants to join some other course, but this time all the information will be same, right? But this time it is not 70, it will be Excel. So she wants to join for Excel, so it will be 10. So that means if I want to get an output something like this, what is student ID? What is student name? What is the location? What is the course he opted for? What is the fees? If I want to know what is the course he's opted for, I don't have the information here. What all I have is only the IDs. So this ID will talk to this ID and this Excel will be replaced here. But simply this 10 will be replaced with Excel and this 20 will be replaced with VBA. This SQL will be replaced with no, nobody has opted for the SQL. So that's an interesting part here. Nobody's opted for SQL and no CID, that's nothing but the course ID is not there. 70, who opted for this Python? Okay. Who opted for the Tableau? Nobody's interested. 30, do you have such course? We don't have. This is something weird actually. There is a person who joined, but there's no such courses opted here. So let's make it as something 70 maybe is looking for a Python, right? What is 10? He's looking for Excel. So tomorrow, if I want to create a table, something like this, 2 tables combined together, I want the final output to be like this. That is student ID, student name, location, course name, and what is the fee is paying. This is how the final output I want. But unfortunately, I don't have this information in the single table. They are presented in the 2 different tables. Now, by using an inner join, what I mean is from 2 tables, it will try to see what are the matching records and it will get only the output related to that information. That means 10, 20, 70, 70, 10 we have, but what is missing here is we have something called 50 is not there. We don't have 60. So what the inner query is, inner joining is saying is from the A table and B table, I'll try to get only matching records. So what is matching here? 10, 10 is matching, 20, 20 is matching, 70 is also matching, 50 is not there, and 60 is also not there. So how the output is going to be? I want to see the output like name of the student, location, course name, and the course fee. Okay, if you want to join this kind of, if you want to see the output, this kind of situation, your business case, okay, then how the inner query is going to behave? It is going to get only the matching record. That's the only intention of inner query. It can do only one job for you, getting the matching records from the both the tables and creating a final result set for you. So let's try to see what is the student table looks like in the SQL. So for that, what I'll do is I'll go to the operators DB. That's a database. Under that, we have tables. Here we have a student table. Let me just drag and drop because I don't want to type in. Here we have something called course table. There's a second table we have. All right. So here I want to say select star from the table. And for the second table also, I want to use select star. Always try to view your tables first. What kind of data we have? Okay. Let me run both in order to see what kind of data we have. So we have 4 students who are from different locations and they opted for 10, 20, 30, 40. That means 10, 20, there is no 30 actually. We have taken intentionally some number which is different. And we have something called 50, 60, nobody opted. Click and Tableau, nobody is looking for. Only we are looking for Excel, VB and SQL, that's it. Okay, so we have 2 different tables here. Now let's try to see how this matching is going to work by using an inner join. So in case of inner join, as we need to remember only matching records we are going to find, nothing else. All right. So how the syntax is going to be, as we are working for the first time on the joins, it is ideally better to start with the syntax first. Once we understand the syntax, writing the query will be easy. Talk about any query for that matter. First, we need to understand the query here. So first we have 2 tables here. Let us keep the queries like that so that I can keep checking. We have select star from the student table. And what is the output you are looking for? That we need to visualize prior to writing the query. So I want a student name. I want the location. I want what is the course he opted for. What is the fee he's paying. So finally, I want a 4 columns from this multiple columns. Tomorrow you have 50 and here 100 columns, out of which you want to see only few columns with the perfect information which you can use for your further analysis. So these are the 4 columns you are looking for. For now, let me try to use a star for time being and to see how it works. Okay, here I'm just writing the syntax here. Okay, this how the syntax goes is start always with your first table. That is your first, whatever the table first you are referring. This is a key here. Okay, in order to make this very life easy, whatever the table name first you are trying to use, that will become your left table. And later, whatever the table you use, that becomes the right table. So for me, student table is the left table and course table is the right table. All right. Now I want to join these 2 tables, what you see here. And finally, I want to see only 4 columns, that is serial student name, location, and I want to see what is the course he opted for and what is the fee he's paying, which is not possible to get with a single queries. We need to join them. Okay, so in order to join them, first I need to understand how to write a syntax. That is first select the columns you are looking for. What columns I'm looking for? I'm looking for only 4 columns. So that columns which you are going to refer here, from which table? That is the table 1. Whatever your table 1, that is your left table is going to be table 1. And here we need to use inner join. Okay, in between these 2 tables, you are going to use inner join. Of which table? That is table 2. Then you are going to use a keyword called on. Let me write in the next line. Okay, you are going to use on table 1. Nothing but here you are going to use the condition. Condition, what the condition mean is the common column reference you are going to use. Because if I want to talk, if I want to make relationship between these two tables, I need to have some one common column. So what is the common column in this is your course ID, and the second table I have something called ID. As I said, the column names can be same or can be different, doesn't matter. But the column which you're saying, like picking up from both the tables, must and should be the same data type. That is the one condition. Second condition is the values should be there. Okay, then only you can build a relation. That means here I have a 10, 20, 30, 40, and if you have some other numbers which are not listed here, so you cannot make a relation there, right? So we need to have some matching records, some not matching records, so that we can see the real fun of joining these two tables by using a inner join. Okay, the query is very easy. When we started using this on keyword, it becomes very lightweighted version of joining the tables actually. But when you're using a where, it's very complicated. We'll see that case as well. So this is a select columns from table one. What joining you're using right now, I know only inner join. I'm using it from which table? That is table two. On is a keyword. On what condition? That's a common column which reference you are going to use. Now let me try to put everything in the form of table. Okay, I'm using straight away select star from table here. Just like the syntax here, I'm not specifying any columns. We'll try to put the columns later. First, try to understand the syntax itself. So select star from table. I'm happy with the syntax. I'm happy with the original line of query. Now I'm using inner join. Which table I want to join? I want to join my course table. So let me take this course table here. Okay, this is my first table. This is my second table. In between that, very important keyword which you used, one type of a join rather, that is inner join, because we are interested to see how the inner join works. After that, we need to use a keyword called on. You can use in a single line everything query or multiple lines. I'm just writing in multiple lines so that you can understand and easy readable. Okay. On keyword. After that, what you want to do? We need a condition, right? So what is your condition? The condition here is student table dot, what is the common column we have? That is from the student table, we have something called course ID. Okay, I'm getting already in the IntelliSense, which is good, is equals to, this is your second table dot, what is the common column in this? ID. That's it. So first I'm trying to select the columns I'm looking for. Here I used star initially to see all the columns. Later we'll try to customize this. Okay, here I'm just in the process of understanding how the syntax, according to the syntax, how I'm writing the query. Then I'm trying to use the inner join. Then I'm using the course table, the second table. That is nothing but the table B, or you can say right table rather. On is a keyword because I'm using a new style join here, that is inner join. So for which I need to use a on key. Here I'm telling my first table dot, okay, the common column reference dot. In this both the tables, the common column is course ID and ID. So that's what I'm saying here. The table dot your column name is equals to the second table dot ID. So here the common column is ID. Here the common column is course ID. I'm just trying to check if it is equal to this, then get me the records. What kind of records? Because I'm using an inner join, the kind of records which you're going to see is, let's see the picture again. A table, student table, B table is your course. In between this, whatever the matching records. So that means if you see both the tables individually, what are the matching records? That is 10, 10, 20, 30, and 40. So these are the only records which you are going to find with the help of a inner join, the matching records. So let me run this and see the final output now. When I run this, I can see 1001, okay, 1001, 1002, 1004. Why? Rest of the columns are not existing, are not matching with that condition. So 10 is existing. Just let me go with my original tables so that you can understand. Let me put all this here and run as a single query. You'll see 3 outputs now. Okay, this is my student table. This is my course table. When I'm trying to join them, what is happening? I'm getting only matching records. 1001 existing here. How? With the help of the course ID, which is a matching record here. 10, 10. Okay, I'm getting 10 here. Then 20, 20 is also matching in the both the records. Yes. And we have 40, 40 is also matching. But how about 30? 30 is not there. I don't have such course called 30, which is giving me any course and it doesn't have any contents of fee. Now, good that we used inner join to see how it works. But now I want to understand, though it is joined, what it is trying to give me the information. Student ID from the first table giving me, it's also providing me the student name. It is also providing the location. It is also providing the course ID. It is also providing ID. It is providing the C name, that is a course name. It is providing the course fee. That means 4 columns plus 3 columns. It is getting me all the columns in a single table. If that is your choice, go for it. But it's not always the same in the real time, because we have in the first table 50 columns, in the second table we have 100 columns. Out of this, we want to be very particular about some columns. Let's take the same example. Here I want to go for only particular columns. So how do I refer that? So let me keep this query aside. And here, instead of star, you need to be very clear from which table you are referring for. Which table you are referring, that is the first primary table, that is a student table. In the student table, I want only S name. Okay, I'm getting from the list, comma. Then what else you want? You want the location. Okay, that's it. You want these 2 columns. Also, you want 2 columns from the other table, that is the C name. Okay, I got it. Then I need C fee. That's it. So that means these are the 4 columns which I'm really looking for from the both the tables once it is combined with the help of inner join, which is going to give me a matching records. Let me run and see how the results are going to be. When I run this, it is giving me the result, but only the choice columns, not everything. But if you look at the name of the student and location are from one particular table, and the other 2 columns, course name and the fee, are from the different columns. Now you can see magically the final output is what you are really expecting. And there is one key here which we need to always remember, which we have seen in the previous sessions, like how to use alias name. Maybe my table name is very simple here, student underscore table, but in the real time, you will not find the table name is so simple. It will be very big names, and it's very not so easy to write them or copy paste again and again, and it looks so busy your query editor. So what I easiest way to do is, for your first table, try to give us some name called A, or let's say S, because it's a student table I want to refer to as S. Okay, very good. Now we have a second table which is called as a C. What does it mean? I'm trying to give a short name, like a other name or a pet name, which I can call throughout my query, so that I can simply call it CS. That's it, instead of giving the complete table name. So now I used S and C. Here, I can replace the entire table name with simply yes. Okay. Then this entire table with C. That's it. Why I'm doing this? In order to make my query simple, lightweighted, and not to repeat the table names again and again with the longer names, I'm just trying to make as short as possible. And it is also better whenever you're trying to give the columns references. Okay, this S name is coming from the first table. That is, what is the table name? Yes. Okay. And the second column is also coming from second table, first table. The third column is not coming from the S table. If I say S dot, I'm not getting that column related information. I'm getting the first table columns, but I don't see C name here. So that means I'm not referring the right table. That is your C table. Once you say C dot, we are getting C name, which is right. And here C dot. Why I'm referring before every column which table you are coming from? The reason is, here we have 4 columns which are unique actually. Had it been, if you have a column like S name in first table, in the second table also, unfortunately or fortunately, if you have S name, SQL will, or your query will get confused. Okay, these 2 are the same column names, common names, from which table he is referring. Okay, in order to make SQL understand, and this is a more most easiest way of writing, always refer the table name in front of it. Just imagine by giving the short names here, how easily I'm able to write quickly and perform my job. If I need to write my original table name, I would have given like this. Instead of S, I would have given the complete table. Instead of S, I would have given complete table. So it becomes so busy and looks like a big query, but it's not. If you just put a short names. Now, when I run this, what happens? You'll not find any change. The thing is, I'm trying to optimize my entire table query much faster actually by giving you short names. Okay, this is about the inner query, and you have seen what exactly the magic it is going to bring when you are trying to combine 2 tables or 3 tables or 300 tables. It's the same format. Okay, so what if I'm trying to combine one more table? You are going to use inner join here, and you'll refer as D because that's a different table. Okay, what if I have a E table? No problem, one more E table. What if I have a F table? No problem, this is the only same way. But when you say on, we need to find one more condition that is coming from comma, then we need to say D dot, again, whatever the common column we have equal to E dot, whatever the condition we have. So that's how we need to just continue with the multiple tables. There's no it's no hard and fast rule. Like wherever you started with the inner join, we can end like this. That means multiple tables you can join just like that. Here I have a 2 tables example. I'm just taking as simple as possible so that you can see the final output very clean way. So let me run all 3 queries at once now in order to see what is happening exactly. So this is my final output, which you're seeing at the top in the top screen. Second screen is talking about second output rather, talking about student table. Here's the third table. My intention was to get student name, location, course name, and fee as a one table, and I achieved it just like that by using inner join, which is a first priority join, which is also called as simple join. So what simple join is doing is just getting the matching records from both the tables. Okay, still there should not be any question why we are not using set operators here. There's a lot of difference. Both are doing the same job might be, but the rules are different. Here my tables column number of columns is not same, still I'm able to join. Data types are not same, still able to join. Okay, the order might be not same, still I'm able to join, but one condition should be matched. Okay, one condition and sub condition, nothing but one condition. The common column should exist in the both the table so that they can make a relation, they can get married to each other, and then they can talk to each other. So one column we require. Again, the column name should be differ or same, doesn't matter, but the data type should same. All right, now let's see how the full join works. Okay, full join or full outer join, what is so called as. So in case of a full join, outer join, here we have 4 records and here we have 5 records. In case of this kind of situation, and you want the output to be shown all the records is this record is already existing in this table. Okay, the course ID is matching, so you'll get 1 record. Okay, and this row is also matching with this record because of this course ID, because this is a common column, we get 2. And the third one, that is this 30 is nowhere existing. That record also I will get, but as a null. Okay, and the fourth record is for Mumbai Nilima 40 is existing, so I'll get 40 as a third record. So that means I'm going to get 10 record, 20 record, I'm going to get the last one 40 record, including that non-matching record also into your group, that is null. So that means I'm going to see 4 records now if I join the table. Is it clear? All right, so let's try to see practically how this full join works. Okay, in order to see the full join works, we need an example again. So here, let me take the same example. Full join, or you can say full outer join. So what do you want to write here? A full join or outer join? The query remains same. but you are expecting this time the output to be different, right? The output you want from the both the tables, whether matching or not, I'm not bothered. Get me everything. That is what the full join talks about, right? So when you're trying to match these two records, whatever the matching record, it will come as ones, but the not matching record also comes without any data. That means it will show as a null. Now let's try to see the output. Now when I run this, one record is not matching, which you have already seen here. This guy who's from Delhi, 30, he opted for a course which is not existing here. So I should be getting as a null. Null for what? If I'm expecting that output to be like this, for this Nani 1003, how the output is going to be? I'll get 1003, I'll get Nani, and the C name null, and fees null, because there is no such record in the course table. But the 1001 Ronnie, you are going to see the full. Okay, with course name, what is 10 stands for? 10 stands for Excel he's interested for, and what is the fees. And the next one, 1002 also I'm interested. I will get this because 1002 is Monty from Chennai who is opting for a VBA. So here I'm going to get as a VBA. And the fee is for that 2000. So that's how you'll get all the matching records without fail, but not matching records also you are going to see in the output, but with as a nulls. The best example would be 1003 record. Let's see as an output now. Now, when I run this, you'll see you are getting all the records. Ronnie, I'm getting, okay, it's existing. Monty also I'm getting, yes. Nani from Delhi, from my first table, these two are available. But stop this. From the second table, if you see, there is no such record called for Nani is not opted for any course. So I'm getting null and null. So that means all the data is retrieved from both the tables, but the kind of, for example, click and tableau, nobody is opted. So we don't have any such kind of a person who is looking for this or location he's from, but we got the nulls here. The best example would be here, Nani. The rest of the things we can avoid because it's not giving me any result as such. But if you look at this example is the best example because this guy is existing in the student table or the employee table, but his corresponding salary details are not available, or in the corresponding course name is not available. So it's showing as a null. So in simple, it will try to get all the matching records and non-matching records with null. Not matching records always will be with null. Matching records with the full information. Like for example, the very first one is the role model here. Ronnie Hyderabad Excel 1000. It's been there in the two tables. Like if you see, Ronnie is existing here and Ronnie is not existing here, but with the help of ID, I'm able to identify, okay, he opted for this Excel and is paid this 1000 rupees. And Monty also existing because 20 is a VBA. So this 20 is going to be replaced with VBA and along with the fee. This guy is existing in the student table. He's just joined, but he is not yet opted for anything, and misspelled or typo error they've mentioned as 30, which is not in my list at all. So here I'm going to get as a final output as a null. And in the course name, I'm going to get as a null, and fee also I'm going to get as a null. That's what happening here. The best example here. This is the best example, and this is the best example. And you can see the last two records for the click and tableau do have this kind of information in my course table, but corresponding to that main table, I don't have any people. I have no students who nobody has registered for these two. So how I'm getting the output? I'm getting click 1500, tableau 3000, but corresponding no location and no student name. All right, let's try to understand how the left join works here. Okay, the word itself is indicating left join. So the left table, whatever the table you take as a primary table will become the left, as we discussed. And whatever the secondary table you are taking, that will become the right table. So whenever you talk about a left, which is just quite opposite to right, if you understand left, right is very easy. So in the right, what happens is it will retain all the data in the A table. That means this is my A table. Let's take this as a A for now to understand better. All these records will be available in the A table. When you are trying to do left join, okay, it will try to get only those records from the table 2 that are matching with the table 1. What does it mean? My table A will remain constant, and from the table 2, it will get only matching records. So what are matching records here now? 10 is a matching record, 20 is a matching record, 30 is not matching, 40 is matching. So that means I'll be getting 4 records from the left table as is. Next, rest all will be the null. Let's see in action now how the left works. Now, in order to understand this better through the help of a graph, let's try to see again. I have a table here, and again we have table called B. Now, what is left mean? Your left table will remain same. Okay, left table will remain same. It will try to get only matching records from the right table, that is this. That's it. This is what your left table is, left join is all about. So that means when you join them, this is how the output is going to be. So your left table is remain constant. It is not moving anywhere, but trying to check from the second table, is there any matching record from my end? And that's how it's trying to get the only matching records. Now, in order to see in action, to see these two tables, now we have better idea what is matching and what is not matching by with these simple tables. Let's go and try to copy the same thing and try to put it in as a next example. This is your left join, or we can also call it as left outer join, whichever keyword which are you going to use, both are same here. So here full join, I'm just removing, simply use left join. That's it. You are trying to make left join now. When I run this, see the result. Your A table will remain constant and you'll get the matching records from the second table. So let's try to understand this more. Ronnie from Hyderabad Excel is opting for 1000 from the both the tables I'm getting, that is Ronnie. And here also we have Ronnie. Actually, this customer or student is not really existing, but it is taking as existing. How? With the help of the matching record, that is with a unique column what we have in the both the tables, that is 10 is matching. So let me get that record. Okay, Monty existing, 20 existing. Okay, let me get the 20 as well. Third one, Nani is existing. He is not existing actually, but why we should get Nani here? Because the left join says my table will remain constant. If I have the matching records from the second table, I will get. Otherwise, I will give a null. That is what it is doing for the case of Nani here, who is from Delhi, and the course is not opted, fee obviously not paid, so null. If you look at the last student, he is matching, so I'm getting the record. So it is trying to get all the records from the table 1 by default. It will remain constant, and only those records from the table 2 that are matching with the table 1 and which are not matching, what it is doing, it's simply trying to put as a null. This is what all about your left. Now, if you try to understand the same with the right instantly, immediately, then you'll understand, you'll have more clarity how the left and the right is behaving in this kind of situation. That is, this is a right and this is a right. Now here I'm just using, instead of left, I'm using right here. Now, before I run this query, I want to see visually how it looks like. So let me go for again paint. Now I'm trying to take left table. This is my right table. Now, how it looks like, your left right table will remain constant without movement. All the records are present, but it will get only matching records from the A table. That's how this table is completed. Now, just opposite to your left table, this is your right. That's it. If you understand left, your right is just opposite to that. Now, let me put this information in the right. Okay. Now, what it is saying, this graph itself is saying, I will remain constant. What? Who is that? Who wants to remain the constant? That is course table, and only matching record from the student table, it is going to get the information. So let's try to see in action now. If I run this, let's try to run both so that the left and right we can see at the same time the results as a two different windows here. Obviously, the first query, first window, second query, second window here. Now, if I try to understand this table, what it is saying is the right table will remain constant. That means all my courses, how many courses are there? Total 5 records. So total 5 records from Excel to Tableau, all records were existing here, and all the fees also available. All the fees also available. But for Excel, who is opted? Ronnie from Hyderabad. For VBA, Monty is opted. For SQL, Nilima is opted. For Click, nobody is opted. Is it true? For the Click 50, there's no 50 record here. So Click is being shown as null. Tableau is showing as null. Now let's try to understand the behavior of the left pattern now. In case of a left, what is happening? All the records from left table, how many people are there in the left table? 4. All the 4 students are existing, but corresponding location is available because it's from the first table. But corresponding course name is not available for Nani because there's no such record is existing in the course table. Fee is also obviously not existing. That's how the left remain constant and trying to check the matching records from the right table. In the case of second table, second output, that is the right join, right table will remain constant. That's how you are getting all the courses here. If you see in the first table, we don't have all the courses. Only matching courses we are getting. But here, right table remained constant by all the course names, and it is trying to see what are we are getting from the left table. Matching records is trying to get. If it is not matching, let me put it as a null. That's it. That's how the right and left works differently, opposite to each other. Again, all right. The next join, after looking at the 4 important, which are most commonly spoke about in the real world, that is the left, right, inner, outer. Inner, outer is quite opposite to each other. Left, right is again opposite to each other. That's how easily we can remember left, right, inner and outer. So let's talk about the next one, that is a cross join. Is that in the list? Let me just look at my text, what I've written here. Union. Full join, right join, left. Yeah, let's talk about the cross join now. In case of a cross join, okay, in terms of a cross join, first of all, let's try to understand what is the cross join, because by comparing the tables, we could easily understand how the left works and right works, but this cross join is little different. Okay, let's see how it works. And this is also called as Cartesian join. Cartesian join, little different pronunciation. Cartesian join. Okay, so whenever you say Cartesian join or cross join, both are same, no change. Inner join like simple join. Okay, left join, left outer join, right join, right outer join. Okay, full join or full outer join. So they're the other names, doesn't matter. The finally the output is same. So here the cross join or Cartesian join, how it works. So let me explain with an example here so that you can easily understand how this works. I'll take a simple example to make this understand. The cross join always get a row from the first table. Okay, let's take this is a T1 table and this is your T2 table. Okay, T1, there's a table 1, this is a table 2. In the table 1, I have 2 columns basically. One is let's take numeric factors for that matter. 1, this is 2, and we have 3. Okay, now A is nothing but 1, 2, 3 is like, assume that these are numbers and these are the names A, B, C. And if you're trying to if you're trying to join these 2 tables, sorry, he's not here. If you're trying to join these 2 tables, okay, where we are trying to join these 2 tables, and what exactly the output is going to be is, it will try to match with each and every record with this table Cartesian, that is what it is called as, that is product of this one row will be 3 times, product of this 2 will be 3 times, the product of 3 will be 3 times. So 3, 3, how many rows you are going to see? Let's see. Now this is 1, this is 1, this is 1. I'm talking about the final output now. Now here I'm getting A, B, and C. This is my output. And here I'm going to get 2. Here I'm getting 3. That's it. This is my final output. So whenever you are trying to combine 2 tables, the Cartesian join always joins This way, every record will be cross-checked with the other table and will be multiplied that many times. So that means here we have a 3 records. Here we have a 3 record. Just for an example, each record is showing thrice with these 3 characters. These 2 again showing as a 3. The third one again showing as 3. So final output is, now you can see how many records. Totally 9 records because we have 3 and 3. So 1 is going for 3, 2 is going for 3, 3 is going for 3. So totally the output would be 9. Okay, that's how the Cartesian, or what you call as a cross join, works. So I repeat, the cross join gets only rows from the first table and then creates a new row for every row, right, in the second table. That's what is happening, right? So T1 is talking to T2 and trying to get every product of that. That's how the result is going to be 9 records. If you have a 10 10 10 into 10, that's how you are going to be you are going to get the output. Let's see practically how it really works. Cross join is again from the new style of table, right? Now I can use simply without joins. I can use, let me see if that really works. Yeah, there is no need of using any. Let me remove this S because I don't want any table names here for this join. I want to remove even, let's take a student table example maybe. Now I don't want this course table. Now we are very clear what table talks about what columns, and this I don't want. Okay, now S name, and we have a location. We have student and cross join course, how it works. So select name, location, and what are the other columns we have? C name. C name. No, C name is not existing from the second one. So let's try to implement in the one a single table first. I think it should work with the single table, not multiple tables. So student table, then of course we is being a cross join. So I need to use cross join with what table? The table is going to be my course table. Let's see how it works. Okay, so select these fields only, or else you can just put a star for now, just to understand how it works. From this table, cross join of this table. Now let me see the output. So how many rows? Okay, now how many rows we have actually? In fact, if you look at each record, Ronnie has recorded this many times. So that means how many we have? Okay, Ronnie, we have only once, but it is being trying to cross check with this table. That means 5 records. So Ronnie has appeared 5 times. Monty has appeared 5 times. Nani has appeared 5 times. Likewise, if you have 4 5s are, that is 20, 20 rows we can see here altogether. 20 rows we can see. This is a Cartesian product. What does it mean is each row from the primary table will try to talk to the another table and it will be multiplied. Example, A table is having 2 rows, a B table is having 4 rows. These 2 rows will talk to these 4 rows to 2 multiplied by 4. That's what happening here in this case as well. Like we have only 4 students, and here in this table we have 5 records. So 4 multiplied by 5, which is nothing but 20 records as a Cartesian data. Resume recording. Yeah. All right. Having looked at the cross join, which is nothing but trying to check, as the cross join is trying to get a row from the first table, that is a table 1, and then creating a new row for every row in the second table or third table or fourth table, doesn't matter. Then does the same for the next row for in the first table. So that means first row is trying to talk to all those rows and creating that many rows. Second row going and talking again to that table and trying to get that many rows. So that's how we are getting Cartesian product, cross join. Okay. The next one is natural join. By the way, natural join is, I think, PostgreSQL and MySQL, which is a product of your Oracle, and Oracle also. Okay, what does it mean? Natural join supported by PostgreSQL, MySQL, Oracle supports this natural joins. That means if you know how to use this natural joins, you can work on this Oracle, MySQL, and PostgreSQL, but not this Microsoft SQL Server, and there's another database, IBM 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 DB2. Yeah, IBM DB2. So these two servers doesn't know what is natural join. That means this natural join will not work in these two servers, relational database management system, whereas natural join works only in these three database management systems. So natural join, but how, if you want to use a natural join, how you can use it? You can use this can be replaced. Actually, let me put a note here so that no confusion. But the same can be achieved by using inner join. Now, what is inner join? We know that like we will get only matching records. So natural join is also going to do the same job, but it will not work in SQL Server. It will work only in MySQL, Oracle product, Oracle. It's an Oracle database. PostgreSQL, that's again a different vendor. It looks like some similar to MySQL. These natural will join will work only in these three categories, but it will not work in MySQL. But if you ask me what is the workaround to work with the natural join, inner join is already doing that job. So there's no need to talk about natural join. If there isn't a question, what is natural join? You can just put the caption of inner join. That is what natural join. But if you can also add up something like where it works and where it doesn't work, that will be more elegant answer to talk about. All right, guys, let's see the next topic, that is self join.